Hello everyone, this is Jean-Paul Jung, Data Modeling and Remote Control for Networks and Security course. Today we will study I2NSF Monitoring Interface Young Data Model. This figure shows I2NSF framework architecture. So this is I2NSF user. In the middle we have a security controller. This is I2NSF analyzer, left-hand side developers management system DMS, and bottom we have multiple network security functions NSFs. Okay, so NSFs deliver monitoring data through monitoring interface to I2NSF analyzer. Analyzes the data using machine learning and send the report or configuration policy to security controller via analytics interface. Today we focus on monitoring interface. Monitoring interface young data model based on this document. This one is I2NSF NSF monitoring interface young data model Internet Engineering Task Force ITF. You can click this link, you can get this document. So introduction to monitoring interface young data model. Basically this interface is used to deliver the monitoring data to enable the collection of monitoring information. Okay, this interface called the I2NSF monitoring interface. So this interface enables the sharing of vital, important data from the NSF, such as events, records, and counters, to an NSF data collector, such as security controller and I2NSF analyzer. So previously, so security controller or I2NSF analyzer can collect the monitoring data from NSFs via monitoring interface. Okay. So the monitoring of NSF plays an important role in an overall security framework if it is done in a timely manner or way. The monitoring information generated by an NSF can be a good early indication of anomalous behavior or malicious activity, such as denial of service, DOS attacks. The use cases for NSF monitoring data. So as mentioned earlier, monitoring plays a critical role in an overall security framework. The monitoring of NSF provides very valuable information to an NSF data collector, such as security controller or I2NSF analyzer, in maintaining the provisioned security posture. Besides this, there are various other regions to monitor the NSF as listed below. So we can see these kinds of variable. Yeah. For example, the I2NSF user, that is the security administrator, can configure policy that is triggered on a specific event occurring in the NSF or network. You can report to consumer face interface data young data model. If an NSF data collector, such as security controller, detects the specified event, it can configure additional security functions as defined by policies. The event triggered by an NSF as a result of security policy violation can be used by security information and event management. It is called SIEM, CM, to detect any suspicious activity in a large correlation context. The information, for example, event, records, and counters from an NSF can be used to build advanced analytics such as behavior and predictive models to improve security posture in large deployment. And also, the NSF data collector can use events from the NSF for achieving high availability. It can take corrective actions such as restarting a failed NSF and horizontally scaling up the NSF. In addition, the information such as event records and counters from the NSF can aid in the root cause analysis of an operational issue, so it can improve debugging for security services. The records from the NSF can be used to build historical data for operation and business regions. So we can see using NSF monitoring data, we can do operation and management purposes. So classifications of NSF monitoring data. In order to maintain strong security posture, it is not only necessary to configure an NSF's security policies, but also to continuously monitor the NSF by checking acquirable and observable data. It is monitoring data. So this enables security administrators to assess the state of the network in a timely fashion. It is not possible to block all the internal and external threats based on static security posture, which means based on monitoring data, we can see dynamics of a network, and then we can take appropriate action in a timely manner. A more practical approach is supported by enabling dynamic security measures for which continuous visibility is required. In essence, this monitoring data can be leveraged to support the constant visibility on multiple levels of granularity and can be consumed by the corresponding functions. So we have three basic domains of monitoring data from this RFC 4949. So we can see retention and the emission from NSFs, notifications for events and records, push and pull for the retrieval of monitoring data from NSF. Every system entity creates information about some context with defined I2NSF monitoring data. And so every system entity that provides such information can be an I2NSF component. This information is intended to be consumed by other I2NSF components, such as I2NSF analyzer or security controller for I2NSF system management, which deals with NSF monitoring data in an automated fashion. So we have two concepts, retention and emission. Retention is defined as storing of monitoring data in NSF, and the emission is defined as delivery of monitoring data in NSF to NSF data collector, such as a security controller or I2NSF analyzer. So the retention of I2NSF monitoring information may be affected by the importance of the data. The importance of the data could be context dependent, where it may not just be based on the type of data, but may also depend on where it is deployed. For example, a test lab and test bed. The local policy and configuration will dictate the policies and procedures to review, archive, or purge the collected monitoring data. For emission, the I2NSF monitoring information retained on a system entity such as network security function NSF may be delivered to a corresponding I2NSF user via an NSF data collector. The information consists of the aggregated records, typically in the form of raw files or databases. For the NSF monitoring interface to deliver the information to the NSF data collector, the NSF needs to accommodate the standardized delivery protocols such as netconf and lastconf. So you can refer to RFC 6241 for netconf, RFC 8040 for lastconf. The NSF data collector can forward the information to the I2NSF user through standardized delivery protocols such as lastconf and netconf. So a system entity such as NSF first retained I2NSF monitoring data inside its own system before emitting the information to another I2NSF component such as NSF data collector like security controller or I2NSF analyzer. The I2NSF monitoring information consists of I2NSF events, I2NSF records, and I2NSF counters as follows. So I2NSF event is an important occurrence at a particular time. That is a change in the system being managed or change in the environment and the system being managed. So an I2NSF event requires immediate attention and should be notified as soon as possible. Okay, so when used in the context on imperative I2NSF policy rule, an I2NSF event is used to determine whether the condition clause of that policy rule can be evaluated or not. The alarm management framework in RFC 3877 defines an event as something that happens which may be of interest. Examples of an event are a fault, a change in status, crossing a threshold, or an external input to the system. In the I2NSF domain, I2NSF events are created following the definition of an event in the alarm management framework. Secondly, I2NSF records. So I2NSF records is defined as an item of information that is kept to be looked at and used in future. Typically, records are the information which is based on operational and informational data, such as the various changes in system characteristics. Okay, so they are generated by system entity NSF at particular instance. This is instance to be kept without any changes afterward. Okay, so a set of records has an ordering in time based on when they are generated. So unlike I2NSF events, records do not require immediate action but may be useful for visibility and retroactive cycle forensics. So this one can be used for digital forensics to figure out some attack later on. So records are typically stored in log files or databases on a system entity over NSF. The examples of records include user activities, device performance, and network status. They are important for debugging, auditing, and security forensic of a system entity or the network having the system entity. The next one is I2NSF counter. So counter defined as a specific representation of an information element whose value changes very frequently. Prominent examples are network interface counters for protocol data unit PDU amount, byte amount, drop counters, and error counters. Counters are useful in debugging and visibility into operational behavior of a system entity. For example, NSF. When an NSF data collector like I2NSF analyzer or security controller asks for the value of a counter, a system entity must update the counter information and emit the latest information to the NSF data collector. So we can define notifications for events and records. Okay, notification is defined RFC 3877 as an unsolicited transmission of management information. A notification is used to deliver either an event or a record via I2NSF monitoring interface. So we can deliver event record using notification. Okay. So the difference between the event and record is the timing by which the notifications are emitted. An event is emitted as soon as it happened. Okay, but record is not emitted immediately to the NSF data collector, and it can be emitted periodically to the NSF data collector. So note that on NSF data collector as a consumer, that is observer of on notification, assesses the importance of the notification rather than on NSF as a producer. Therefore, the producer can include the metadata in a notification that supports the observer in assessing its importance, for example, severity. So we have a push and a pull for the retrieval of monitoring data from NSF. So an important aspect of monitoring information is the freshness of the information. From the perspective of security, it is important to notice changes in the current status of the network. The I2NSF monitoring interface provides the means of sending monitored information from the NSFs to an NSF data collector like I2NSF analyzer in a timely manner. So monitoring information can be acquired by a client, such as NSF data collector, from a server. Server is a NSF, okay? So using push or pull. So push is a query-based method. Okay, pull is a query-based method, and the pull is a report-based method. Okay, so pull is query-based method to obtain information from the NSF. Okay, so NSF will remain passive until the information is requested from the NSF data collector. Okay. On the other hand, the push case to obtain information from the NSF, the report-based method ensures the information can be delivered immediately without any request. Okay, this is a push. Okay, these acquisition methods are used for different types of monitoring information. The information that has a high level of urgency, such as the I2NSF event, should be provided with the push method, while information that has a lower level of urgency, such as I2NSF record and I2NSF counter, can be provided with either the full method or full method. So let's take a look at basic information model for monitoring data. So there are many data from NSF. Okay, so firstly, there must be some general information with each monitoring message sent from an NSF, helping a consumer to identify metadata with the message, which are listed as below. So message, extra detailed description of NSF monitoring data, and vendor name, and the device model, and the software version, NSF name, the name or IP address of NSF. Okay, so it may be FQDN, fully qualified domain name such as DNS name. Note, this name must be unique in the scope of management domain for different NSF to identify the NSF that generates the message and timestamp the time when the message was generated, and the language describe the human language intended for the user or administrator, so that it allows a user to verify the language that is used in the notification, like the English, United States English, okay, is a default language. So, and also we have extended information model in addition to a basic information model. So the extended information model is the specific monitoring data that covers the additional information associated with the detailed information of status and the performance of the network and the NSF over the basic information model. The extended information combined with the basic information creates the monitoring information, such as I2NSF event, record, and counter. So we have two kinds of the fields for extended monitoring information: acquisition method and emission type. So acquisition method is to obtain the message, query, or subscription. So query is a request-based method to acquire the solicited information in order to get, like this one is similar to the full, okay? And subscription is report-based method that pushes information to the subscriber, like this one is the push, okay? Report-based method, okay? And the emission type, the cause type for the message to be emitted. This attribute is used to only when the acquisition method is a subscription method, okay? So we have two things. One is an on-change message, the other one is a periodic message. On-change message is emitted when an important event happens in the NSF. Periodic message is emitted at a certain time interval. The time to periodically emit the message is computable. So note that the characteristic information is not mandatory to be included in a monitoring message. And we have also another characteristics for extended monitoring information, damping type. This is the type of message damping to stop the rapid transmission of messages. Okay, if the message is keep sending, kind of denial of service attack, right? So the damping types are on repetition and no dampening. The on repetition type limits the transmitted on-change message to one message at a certain interval. For example, 100 centiseconds. This interval is defined as a dampening period in RFC 8641. The dampening period is computable in the unit of centiseconds. The no dampening type does not limit the transmission for the messages of the same type. In short, on repetition means that the dampening is active and no dampening is inactive. So activating the dampening for on change type of message is recommended to reduce the number of messages generated to avoid the overload to handle monitoring data. Okay, so let's take a look I2NSF monitoring data one by one, the counters. Okay, so the counters, we can see there are three types of monitoring information: event, record, and counter. So counter provides visibility On the ongoing network, two counters are defined in the monitoring Yang model, such as the system counter and NSF counter. System counter defines the interface counter to look into traffic into and out of on NSF interfaces. NSF counter defines the firewall counter and the policy hit counter to look into a specific traffic based on a given configuration of on NSF. So both system counter and NSF counter information has the following characteristics: acquisition method, emission type, dampening type. Acquisition method is a subscription over query. Emission type is a periodic. Dampening type is a no dampening. So we have interface counter. Interface counter is a important example. So these counters provide the visibility into traffic into and out of on NSF, okay, such as the firewall and bandwidth usage. The following information is included in the interface counter: interface name, protocol, the type of network protocol, measurement time, the duration of the measurement in seconds for the calculation of statistics, such as the traffic rate and throughput. And in total traffic package, out total packet traffic packets, in total traffic bytes, out total traffic bytes in terms of total outbound byte. So right hand side we can see I2NSF counters Yang tree, and also other in out traffic packet and the traffic byte we can see. Also total traffic, in traffic average rate, in traffic peak rate, in traffic average throughput, in traffic peak throughput, such as inbound traffic peak throughput in bytes per second, right? So this is a system interface, okay? Especially interface counter, system interface have these kinds of fields, okay? So this one is the type of this element, okay? So let's take a look. Second one is firewall counters, okay? So provide the visibility into traffic signatures and the bandwidth usage that corresponding to policy that is configured in a firewall. So the following information included for firewall counters: out traffic average rate, outbound traffic average rate in packets per second. This one is out traffic. Those are out traffic, right? Peak rate, average throughput, peak throughput. And this continuity time is important. This is the time on the most recent occasion at which any one or more of the counters suffered this continuity. If no such discontinuities have occurred since the last reinitialization of the local management subsystem, then this node contains the time the local management subsystem was reinitialized, okay? So this one is NSF firewall, okay? So it has the firewall related counters, okay? We can see, okay? And the policy hit counter, third one, record the security policy that traffic matches and its a hit count. That is when a packet actually matches a policy, it should be added to the statistics of a policy hit counter of the policy, okay? So the policy hit counter provides the policy name that matches the policy name in the NSF facing interface Yang data model. You can refer to this NSF facing interface Yang data model. It can be used to check if policy configuration are correct or not. So the information include the policy name, hit times, and discontinuity time. So right hand side we can see NSF policy hit Yang tree. Let's move on. The second category is I2NSF event. So event has actually three kinds of things: system alarm, system event, and the NSF event. System alarm provides memory, CPU, disk, hardware, interface alarms. This is hardware resource related alarms to get a warning regarding the system hardware. System event provide access violation based on access control list, configuration change, session table event, and traffic flows to get a warning about the changes and violation happen in the NSFs. The last one is NSF event provide the event that is detected by a specific NSF that supported a certain capability, such as DDoS attack detection, virus event, intrusion event, web attack event, and voice over IP and voice over cellular network event. System alarm system event NSF event information include the following characteristics: acquisition type, emission type, dampening type. Okay, so the first one, acquisition method is a subscription, emission type is on change, dampening time is on repetition or no dampening. First, I2NSF event is system alarm. So memory is hardware to store information temporarily, right? Like random access memory RAM. So memory alarm is emitted when the memory usage exceeds the threshold. Okay, so the fields are like this: alarm category, usage threshold, severity, and message. Okay, severity case critical, high, middle, and low. Okay, so message is human readable text, like the memory usage exceeded the threshold for extra information. So right hand side we have notifications, specifically system alarm. Okay, we can see the fields, and then second one is the CPU related one. So CPU stands for Central Processing Unit. Okay, executes the basic operations of a system. So this alarm emitted when the CPU usage exceeds the threshold. Okay, the information include this kind of thing. Alarm category is CPU alarm, usage threshold, severity, and message. Okay, so right hand side we have the system alarm related CPU. Okay, and the third one is the disk over storage system alarm. Similarly, emitted when the disk usage exceeds the threshold. Okay, the fields are alarm category, usage threshold, severity, and message. And hardware alarm. This one is general hardware alarm. So alarm category, component name, severity, and message for human, the administrator. And interface, network interface related system alarm. So emitted when the state of interface is changed. Okay, so the information includes alarm category, interface name, interface state, like up, down, up, no conjected, up but conjected, testing, unknown, dominant, sleeping, not present, and raw layer down. Severity, we have for severity, and message for human, for administrator. So this is system alarm for interface. And second category, system event, like access violation, okay, happened, okay, based on the access control list. So the following information includes event category is access violation, and the identity is like that, user group IP address, and the layer 4 transport layer, port number, and the authentication. The method to verify the valid user, such as the pre-configured key and the certificate authority, and the message for human analysis, such as access is denied. So this is the system event Yang tree. Okay. And also configuration change. Second, one of system event category, right? So this is new configuration added, or existing configuration is modified. So the fields are event category, identity. Okay, identity also similarly consists of user, group, IP address, layer 4, transport layer, port number, and configuration change. So also we have authentication message changes. Okay, so the authentication is a message verify valid user, pre-compute the key, or certificate authority CA based one. So message is human readable text. Configuration is modified, or new configuration added, or a configuration has been removed. The changes describes the modification that was made to the configuration. Okay. And the system event, the session table event, defined as a connection, traffic flow over data plane like TCP, UDP, and SHTP transporter layer. So session table event is the event triggered by session table of an NSF. Okay. So this table holds the information of currently active session. So the fields are event name, current session, maximum session, threshold in terms of allowed number of sessions triggering the event, message, such as the number of sessions exceeded the table threshold. So right hand side we can see system event for session table event here. So traffic flow, okay, traffic flow is event triggered by a specific traffic flow and should be recorded. Okay, so the event name, interface type, source MAC address, destination MAC address, source destination IP addresses, source and destination port numbers. So here we have traffic flow system event Yang tree we can see, and also the protocol measurement of time. So the duration of the measurement in seconds for the arrival rate and arrival throughput of packets of traffic flow. Arrival rate and arrival throughput are maintained. And then NSF events, DDoS detection, such as denial of service or distributed denial of service, DDoS attack. So those events describe the event name. Specifically, we can specify attack type like scene attack, egg flooding, something like that. And then attack source IP addresses, attack destination IP addresses. We can see this is the Yang tree for that. And the event also attack source port, attack destination port, start time and ending time for this one. Okay. Okay. So right hand side we can see NSF detection DDoS attack. Okay. So start time, end time field we can see the attack starting time, and also with the end time we can see attack end time, and also attack late, attack throughput, and the rule name. So the name of I2NSF policy rule being triggered for this attack. So you can report to I2NSF and as a face interface data model. And then virus event. Virus is detected within a traffic flow or inside a host. Okay, so this information include the event name, virus type, and the following information is used only when the virus is detected within the traffic flow. So source, destination, IP address, and the source and destination port numbers. And within the host system, virus event case, host, the name or IP address of the host device that is impacted by the virus, and such as QDN, DNS name, and operating system, file type, and file name, and rule name, the name of a rule being triggered. And the intrusion detection, using intrusion detection system ideas, intrusion prevention system IPS, okay, is used. So the fields are event name, attack type, source destination IP addresses, source destination port numbers, and the protocol, and the application layer protocol, and the rule name for policy rule being triggered. So this is the Yang tree for intrusion event. And then in the similarly web attack event, when an attempt to attack to the web server, so the URL filtering is used to detect illegal access to deny the web server. The information includes event name, attack type, source destination IP addresses, source destination port numbers, request method, HTTP method, and request the target and the response code. And then web attack event also includes cookies, request host, and the filtering time, and the rule names already included. And the voice over IP, voice over cellular network case, when a voice over IP and voice over cellular network attack is detected, the fields are event name, source voice ID, destination voice ID, user agent, source destination, IP addresses and port numbers, and rule name. So those are the voice over IP, voice over cellular network, the I2NSF, NSF event, Yang tree. And records. So records provides less urgent information on ongoing network, such as system log, NSF log. So system log is a record that is used to monitor the activity of a user on the NSF and the status of the NSF. System logs provide access log, resource utilization log, and user activity log. Okay, so NSF log is a record of an attack that is detected by an NSF with the specific capabilities. Okay, so such as the packet inspection DPR log is an example. So we have a Yang tree for system logs, access logs. Okay, so record the administrator's login, logout operation, something like that. Okay, so the information, the identity using user, group, IP address, and transfer layer, layer 4 port number. So right hand side shows the access log. Okay, system access log. And also the access log includes authentication method, operation time, input, output. Okay, and then resource utilization log records the device system's running status. Okay, for device monitoring. The information includes the system status, CPU usage, memory usage, disk ID, disk usage, disk space left. And also session number, process number, interface ID, traffic rate, and the traffic throughput are also monitored. And the user activity log case, the user's online records the login time, online logout duration, login IP addresses. So identity information and authentication, online duration, logout duration, additional information for login and type, user activities, and the cause of failure, user activity. Right side shows user activity logs. And the packet inspection DPI log also have these kinds of attack type, source destination IP addresses, port numbers, rule name, and actions. Okay, so we have examples. Yang monitoring event stream. So Yang module, this one shows event stream. Okay, so the reserved event stream name for this document is I2NSF monitoring. So NetConf server, such as NSF, must support I2NSF monitoring event stream for on NSF data collector. So event stream contains all NSF events described in the previous section. So the following XML example shows the capabilities of event streams generated by on NSF, such as netconf and I2NSF monitoring event stream. For the subscription of on NSF data collector, refer to RFC 5277 for more detailed information. So this shows RFC reply, netconf comment, and then streams for monitoring event stream, netconf report netconf stream information. So this is I2NSF monitoring subscription. Okay, and the examples following example shows memory usage. This example XML is delivered, right? So this one case, the time-based firewall, the memory of the NSF trigger alarm, and then script method specified, okay, on repetition and emission type. This one, the subscription is acquisition type, emission type, dampening type, and the language. And then I2NSF system detection alarm is specified. The memory is usage is this one, and the threshold 90, okay? And then this is the message for the user administrator. Severity is high, okay? This is a report, kind of a notification, right? Notification. And the second one is system interface counter information by query. So NSF client needs to initiate the get connection with the netconf server. So following XML file shows how to get the status data and filter the information. So this is RPC, right? So get filter. So this is a monitoring interface. So I2NSF counter system information is described. Okay. So this is a subscription for this I2NSF system interface information. Okay. The next one is shows the firewall-based firewall reply. So if there is the previous this one, we subscribe certain this kind of memory usage happen, we can generate, right? So this shows the traffic byte, and then this system interface information, and then NSF that sends the information named the time-based firewall acquisition method, and the two system interface elements included, each containing data about the specific system interface. Also, this continuous time element specified time when the data was last reset. And finally, interface name element specified the name of a system interface. And then the traffic byte, drop byte, and NSF name specify the name of a network security function that generated the data. So this one shows the NSF, especially time-based firewall. Okay. Conclusion: I2NSF NSF monitoring interface, Young data model specifies the data models for the monitoring of NSFs. Monitoring of NSF provides very valuable information to maintain a network security posture. I2NSF monitoring information consists of I2NSF events, records, and counters. With this information, it is possible to detect the indication of malicious activity, anomalous behavior, potential sign of DDoS attack, or system overload in timely manner. In the class, the usage of I2NSF monitoring interface Young data model is shown with the example. If you have a question, please let me know. Thank you for your attention.